In this example, we will demonstrate using the low-level TCP component called CorePort TCP. Firstly, we'll host both ends of the TCP communication within the one process. Next, we'll then demonstrate the same example communicating across processes. To test both scenarios, we'll use the Savantec generic client tool. Let's get started with the first example. Start Solution Builder now. Drag our first CorePort TCP component onto the design surface. Rename it Client. As I am working on a Windows 7 machine, I'll change the IP address family to version 6. To use my local computer, I'll specify the loopback address of localhost for both local and remote host parameters. Now drag another CorePort TCP component onto the design surface. Rename it Server. Change the IP address family to version 6. Again, update the local host and remote host parameters to use the loopback address of localhost. Change active to false. The server is the passive end of the TCP communication. Also swap around the local and remote port numbers. Let's now save the solution in our examples folder. C:*examples. Give it a name of TCP client server example. Start the solution running. Check the log to ensure both components started successfully. If you get a socket error, double-check to ensure the port numbers aren't already in use. Now we have the solution running in the Solution Builder process. We're now going to start 2 instances of the generic client to test the TCP communication. Select the client component on the design surface and launch the generic client. Click on the Tools, Generic Client menu. Repeat the process for the server component. Select the server on the design surface and launch another instance of the generic client. Return to the first instance of the generic client. The component connection is displayed in the status bar. Expand the CorePort node. Select the first sent node and expand it. Edit the data parameter. Enter the uppercase letter A. Click on the send node and execute the method by clicking on the send button. The log will update to show the send method call. Return to the Solution Builder and view the log. As you can see, the client has sent the byte 65, which is the value for a capital A. The server has received the byte 65. Switch to the generic client, connected to the server component. As you can see, the log contains a record of the data received. Just to recap, in this scenario we hosted 2 components in the same Solution Builder process and communicated over the network via TCP. We used the generic client to talk to the client CorePort TCP component over the CorePort interface, invoking the CorePort interface send method. In the next scenario we will create 2 solutions, one for the client and another for the server. Each solution will run in a separate instance of Solution Builder. Let's get started. Open Solution Builder and create a new blank solution. Drag a CorePort TCP component onto the design surface. Rename it Client. Change the IP address family to version 6. Update the local host and remote host parameters to use the address of localhost. Save the solution in our examples folder, C:examples. Give it a name of TCP client example. Open another instance of Solution Builder. Drag a CorePort TCP component onto the design surface. Rename it Server. Change the IP address family to version 6 and update the local host and remote host parameters. Swap the local and remote port numbers and set the active property to false. Save the solution as TCP server example and start it running. Switch back to the instance of Solution Builder running the client. Start it running. Check the log for any errors. Select the client component on the design surface and start the generic client. Invoke the send method using A as the value for the data parameter. Switch back to the instance of Solution Builder running the client. Check the log window. As you can see, the client has sent the byte 65. Switch back to the instance of Solution Builder running the server component. Check the log window. As you can see, the server has received the byte 65. Just to recap, in this scenario we hosted two components in separate Solution Builder processes and communicated over the network. The TCP component is a low-level communication building block that can be used in a variety of scenarios. If you need more detailed information, please view the Cortegral developer help file. Thanks for watching this training video. If you have any questions or suggestions on how we can improve our training material, please contact us. Goodbye.